All right, ladies and gentlemen, we're looking at 5.3 bisectors of a triangle. We're going to use properties of perpendicular bisectors of a triangle and use properties of angle bisectors of a triangle. A perpendicular bisector of a triangle is a line or ray that is perpendicular to the side of the triangle at the midpoint of the side. We talked about these yesterday. We talked about the point of concurrency. An angle bisector is a bisector of an angle of a triangle. The point of concurrency, we remember the point of concurrency is where they all meet. So an angle bisector is where
Won't you just start giving referrals? I'll give it a picture over.
Yeah, people don't do them perfect. Okay, so if we've got a triangle and we're cutting the angles in half, so we have to cut the angle in half, we cut the angle in half, we cut the angle in half. That point of concurrency, and you'll have to know this for the quiz, is called an incenter. So you might want to make note cards for yourself, like incenter, point of concurrency for angle bisectors. Okay? Converse of angle bisectors. If a point is in the inner center of an angle and is equidistant from the sides of the angles, then it lies in the bisector. Okay, so this incenter is the same distance from all the sides. So these green lines all have to be the same length. Does anybody remember the perpendicular bisectors point of concurrency was the same distance from all the what? Anybody remember from yesterday? Not all the sides, but all the vertices. Okay. Okay. Concurrency of an angle bisector. The angle bisectors of a triangle intersect at a point that is equidistant from the sides. Okay, so now we're going to look at example 1. Come on. We're going to look at the perpendicular bisectors of ABC meet at point D. We know that A, this is A, E, please stop talking, I'm talking, B, D, F, C, and G. We know that A to B, this whole thing, is 22. We know that A to D is 14. Okay? We want to find D to B. Now these are perpendicular bisectors, which means the distance from the point in the middle, the point of concurrency, to the vertices have to be the same. So, what is DB? 14, which is the same as AD. All of these are the same.
Can't you say it's just half of 22?
You don't always, it's not half 22. Half 22 is 11. You're talking about the mid-segments. These are not mid-segments. AE is what?
Oh, that's 11.
That's half of 22. All right, let's look at example 2.
That's all we got to do for the homework.
That's perfect, yeah. Let's look at example 2. We're going to use perpendicular bisectors again. We know that, Murphy can't carry the labels over. U, U, O, S, R, P, T. Okay. Shh. We know O to S is 10. We know Q to R is 12. We know P to Q is 22. Okay. These are perpendicular bisectors again. So we know that the lengths from the center to where are the same. Perpendicular bisectors, the center to the
Sides.
vertices.
Yeah.
Vertices. These in red are all the same. Okay. O to P would be what? Right, because O to S is 10, so O to P would have to be 20. because the perpendicular bisector bisectors cut in at the midpoint? R to P. 12. So that has to be the same. O to R.
12.
12. Yeah.
Wait.
Has to be the same. T to P.
11.
11. So it has to be half.
20.
Okay. All right, we ready to look at the next one? Now, are these perpendicular bisectors or are these what? What does it say?
Angle bisectors.
Angle bisectors. Do we remember how angle bisectors are different? Angle bisectors, the distance from the center to the sides are the same. So all of those in green are the same one. Okay, we know we're given that D to C is 28. We're given that F to D is 17. And we want to find all the other measures if possible. D to E would be what? 17. B to D. B to E, we don't know. Why don't we know?
B to E.
Because what are these? These are what?
They're not congruent.
They're not congruent because it's angle bisectors, not perpendicular bisectors. G to D.
17.
17. Do you know D to A?
28.
Isn't 17?
D to A we don't know because we don't know that the distance from the vertices to the middle are the same because they're angle bisectors. All right, let's do the next one. And then we will be done. So what is really important when you're doing your homework? You've got to be able to know the difference between
Angle bisectors
angle bisectors and perpendicular bisectors, right? Okay, so this is example 3. Example 4 is a what?
and angle bisector.
Angle bisector, which means what are the same? The middle to the sides. Good. So I'm going to draw that in so I know the middle to the sides are the same. Okay, and I know that P to R is 3. P to C is 5. Okay. What is B to P?
Don't know.
Don't know. What is P to Q?
3.
What is Q to C?
Don't know.
Oh,
We do.
what kind of triangle is it?
Right triangle. It's 5.
Okay. This is a side, and this is a hypotenuse. So it's 3 squared plus, we'll call it x. X squared equals 5 squared. And what is that called, what I'm doing right there?
Pythagorean theorem.
Right, so x is 4.
I knew that, yes. Precisely.
We know this right here is a right triangle. We know this length is 3 and this length is 5. So we use Pythagorean theorem to find that the third side is 4. 3 squared plus 4 squared equals 5 squared.
So we'll use
I know this is x. This is my unknown side. So 3 squared is 9. 5 squared is 25. 25 minus 9 is 16. The square root of 16 is 4.
Oh, okay.
Okay. Do you want me to show that whole thing out, or are you okay?
No, we're good.
You guys also, have you heard of 3, 4, 5 triangles? There's a special triangle. If you know one side is 3 and the other side is 5, the other one has to be 4. Okay, that's why I can do it so fast. I didn't do all that. I just knew about special triangles.
Isn't like the 30, 60, 90?
Uh-huh.